Hi everyone, my name is Jolien from Consortix and I'm going to guide you through some features of SAS Visual Statistics. I'm going to do this with the help of this demo that aims on optimizing your current AML solution. We imported a database that contains all generated alerts, together with the knowledge if this was indeed an alert or a false alarm. This gives us an idea on how true and false alerts are distributed in our data. In this case, we have 5,825 true alerts and 42,943 false alerts. Before diving deeper into the scenario analysis, you can also conduct analysis on your investigators. And here we see a bar chart where each bar corresponds to an individual investigator and a color indication to represent how many times an investigator chooses a specific reason for closure after investigating that alert. A possible interpretation could be that investigators 3 and 6 are newly hired, which explains their lower overall number of investigated alerts. Remember that this is just one possible interpretation and that it all depends on the context of your AML system. This next screen provides us with a first impression about the impact and performance of the different scenarios used in our AML system. The scenarios are represented in a tree map where the size of each tile suggests how much a scenario occurs, and the color gradient gives an idea about the false positive rate of each scenario. By this false positive rate, we mean how many times a scenario triggers an alert incorrectly. And when we have, for example, a scenario with a false positive rate of 79%, this means that in 79 out of 100 times a scenario says a transaction is an alert that in fact should not be alerted. How darker the color, how higher the false positive rates, and from the optimization perspective, we're interested in big and dark blue tiles to fine-tune first, because they improve your AML solution best. Moving on, we see a next visual regarding the performance of the different scenarios. And each scenario is now represented by a bar, with on the vertical axis the true positive rate, or in how many percent of the cases a scenario flags an alert correctly. A color indication was added to show the portion of alerts for that scenario for each customer segment. In this case, an alert belongs to either the governmental sector in red, private sector in yellow, regular sized businesses in green, or small sized businesses in blue. There are some scenarios that stand out, so let's take a closer look and see what they tell us. Scenario 10 is about structured cash deposits and doesn't have a bar at all, telling us that it doesn't generate any true or positive alerts. This could mean that this scenario is unnecessary, but more interesting would be that the reason for its poor performance is due to wrong parameter settings, on which we'll come back later. Scenario 28 alerts rapid movement of funds international to cash. It has a good true positive rate of 80%, but doesn't contain any true alerts regarding the regular sized businesses. We could ask ourselves the question in what extent this segment is different to the others, or whether the parameters have to be reviewed so that we catch alerts for this segment as well. Scenario 12 covers large cash withdrawals, and 41 is about high weekly amounts by a monitored country customer, only catch alerts for the private sector and so tell us that they are specific scenarios for that segment. This might be logical because it is unusual for individuals to withdraw large amounts of cash or do a lot of transfers to monitored countries. When one of those apply, it is almost certain that this is a real alert. It is also possible to analyze and optimize individual scenarios. So let's take scenario 5 as an example. Scenario 5 is about large cash deposits, and the database told us that the amounts corresponding to each alert for the scenario has a range between 20,000 and 1,800,000. This data was portioned into different intervals, and on the vertical axis we get the absolute numbers of true and false alerts in blue and green respectively per interval. And for the first two segments you see that true alerts as well as false alerts appear, indicating that fine-tuning can be done. So let's take a closer look. From the data, we derived that currently a uniform parameter was used for the different segments of 20,000. But out of this graph, we can tell that it could be smart to raise the parameter to 30,000 for regular sized businesses because true alerts only start to appear at this interval. You can easily see this because there is no green color in the first bar. Let's take scenario 21 as a second example. And scenario 21 is about large deposits into new accounts. And we did the same analysis as we conducted on scenario 5, but in a slightly different visualization. Different as with scenario 5, we here see that the AML solution already handled different parameters for the different customer segments. And you can see this by looking at where the first bar appears. Decision trees are a very useful and powerful tool in SAS Visual Statistics, and they help you with finding the strongest combination of scenarios. What is so powerful about decision trees is that when you add different scenarios or rules to the tree, SAS Visual Statistics will automatically provide you with the best performing model. Let's look at an example to make this more clear. The first node again represents the distribution of true and false alerts and is exactly the same as in the very first graph. Then a partition is made whether a transaction was made on behalf of a high-risk country or not. When this is the case, we already see an improvement in the true positive rates. We go from a true positive rate of 22% towards 33%. Next, the customer's employment is considered and the node is split up in 4 new ones, one for each employment possibility. We see the biggest improvement in the nodes of part-time employees, where the true positive rate went up from 33% to almost 56%. So by combining these two rules, we can say with confidence of 56% that a transaction conducted by a part-time employee to a high-risk country is a true alert. Based on the data that you provide to SAS Visual Statistics, it is also able to make valuable forecasts. And here we see a forecast about the amount of alerts that our AML solution is going to generate in the near future. But even more interesting is the next feature. When an underlying factor is added, like the true positive flag in this case, you can do scenario analysis. This screen will pop up where you can see the impact of different frequencies and alerts. When we expect, for example, that the amount of alerts will be higher in this period, but lower in this period, and then apply these changes, we will see how this affects the true alerts like now. Down here, you can see that forecast has a confidence of 95%. To finish this demo, I want to show you this scatter plot. And we again use scenario 5 as an example. Each data point represents the withdrawal amount and number of withdrawals for each alert. The color indicates whether the alert was positive in red or false in green. When looking from a distance, you can draw an imaginary line that personates the current handle parameter for the cash deposit amount, which is 19,000. All transactions with an equal or a higher amount are alerted. It is now possible to fine-tune the scenario by raising the amount parameter according to your risk appetite. We raise the amount parameter to 22,000, for example, but this has some consequences. You significantly lower the amount of false alerts, which will on its turn significantly reduce the amount of work for your investigators. But you will also miss out on 4 true alerts. So hereby I want to end this demo, and I hope it was useful for you to get to know SAS Visual Statistics a little bit better. Notice that this was only a part of all functionalities of this tool. And if you have any further questions or want to schedule a demo, please feel free to contact us. Thank you.